Physics Practicals Video 2. Now we are going to discuss about the methods of data collection. Now in the earlier video we learned about identifying the dependent, independent and control variables. Now we need to find out how to do the experiment. Now doing the experiment means we have to change the independent variable. Then how do we vary the independent variable? That is, we need to change it. How do we change it? Then how do we measure the change that we have given it? Then as a result, the dependent variable will change. Then how do we measure that? Then how are we going to maintain or control? How do we control the control variables? So this is what these are the steps involved in the reaction in the experiment. So if we identify these things, then we will be able to complete the reaction. First, we identify the dependent, independent, and the control variables. Then we identify how do we vary the independent variable and how do we measure that change. Then as a result of the changes in the independent variable, the dependent variable will also change. Then how do we measure the dependent variable? And then how do we maintain or control the other variables, control variables? How do we control them? And finally, you should be able to you should be able to use a label diagram. It needs to be clear as well. And remember, this is not art. So you don't have to shade or do anything of that sort, and you already know how to draw these practicals. So you have to use a two-dimensional clear diagram, and you have to name it. And also remember, sometimes some things are now, for example, if it is a fan, you might not, you might feel, okay, this is so obvious to be named, but still you need to name it, because if you have not named it, it is not part of the experiment. That is something that you need to remember. So then when you are thinking about this experiment, after you have read the question, when you think about this experiment, you might get different ideas that you might forget to write. So then when you are reading it, every time you remember a step, please write it down in a rough sheet of paper. You write it down, and when you are going on with the explanation part of the experiment, just check whether you have forgotten to mention anything. So then you would be able to write a complete description of the experiment that you are going to follow. And like they say here, if you have not written down a certain part of the experiment, that means it is not part of your plan. So they are not going to give you points for that. Just because you have it in your mind, they cannot know that. So they will not give you points. So always you need to have said these things. What are the things you will have to measure, and how are you going to measure it, along with its units, if it is applicable. Then what are the things that you are going to change, and how are you going to change it? Then what are the things that you are going to keep constant, and how are you going to keep them constant? So these three things, that is the dependent, independent, and the control variables, how do you change them, how do you measure them? Those are the things that you must write. They should be a part of your explanation. Now when you describe the experiment, right, so you identify the dependent, independent, and the control variables, and then you have to describe. The first thing that you need to do is you describe what you change. That is, the independent variable needs to be mentioned. How are you going to change it, and how are you going to measure it? Now in this particular situation where we are going to measure the effect of the speed of a jet of air. So here, what do you need? You need to use your general knowledge. And sometimes the experiments that you get might not be something that you have ever come across in your life, but still you should be able to use the general knowledge that you have used in other practicals to figure out what exactly is needed of you here. So here you might be able to use a wind fan, or you can say you can use a cover that give cover in front of the wind fan with a hollow tube that comes through from it. So that means you can change the position of that hollow tube. It is something like this. If I am to draw, now this is, let's say this is the fan, right? So this is the fan. From this fan, air is blowing in this direction. What you do is you put a cover in front of it with a hollow tube. So this end is open. So the air will be coming out of this. So then you can change the direction and by lowering and increasing the height of the fan, you can change it, and also you can focus the air on the balloon. So this is something that should come from your common sense, and also it should be something that you should be able to draw and explain. You should draw and explain how it is done. Then how are you going to measure? Now you know that you have to change the way the independent variable is the thing that we change, that is the speed of the air. So how do you change it, right? Then you can use you use a fan that has an adjustable power supply. So you adjust the power supply to the fan, and thereby you change change its voltage and the rotating speed. So then you can change the speed of the air blow. Then how do you measure the wind speed? Then you might this wind speed can be you can use a wind speed indicator. If you do not know the specific name, you can say wind speed meter, right? An instrument that measures it. This is actually, there is a specific name for this meter, anemometer. So if you know them, then you should write it, anemometer, and also explain what it does to measure the independent variable, that is the wind speed. Please be generous with your words. Please be generous with your words. That means, like I told you earlier, that you have to make it short and sweet, but that doesn't mean that you have to, this is about explaining. In the first instance, you have to say, you don't have to go into stories. This is the reason why this is independent variable. No. When you identify the independent, dependent and control variables, you have to be specific. You say that this is the independent variable, this is the dependent variable, this is the these are the control variables. But when you come to explaining, when you come to describing, you have to be very generous with your words. That is, you don't have to write stories, but what you need to do is you have to make sure that you explain it properly. So all the things that even you feel that even an idiot would understand, you have to write it. You have to think that an idiot is going to read this answer, right? So please make sure that that it is done like that. So you can think that it is me who is reading the answer. So I'm an idiot. So write it in a way that I would understand, right? So you might never have used an anemometer, but still you might not know about an anemometer. You might not know that exists, but from general knowledge you have to mention that we need to use some instrument that measures the wind speed. So you have to be very careful, and you have to mention a sensible instrument. That means don't try to create another experiment to develop something that requires that measures this. So you have to think about something simple, but something that can be used easily. So if you are talking about something new, that is some quantity that you have never met before, then you will have to be very careful. So the practice will help you a lot. Then the independent variable is fine now. So we have the independent variable and we know how to measure that. Independent variable is the speed of the airflow, and the instrument is anemometer. So we have explained that. Then we come to the dependent variable. Dependent variable is an angle. How do we measure the angle? Using a protractor. So when you think of a protractor, you might think of the protractor that you have in your instrument box, but it is not the only protractor that you will find in existence, right? There are protractors which are quite large. So you might want to say you use a large protractor, or else you can use the trigonometric ratios to find the angle as well. You find the height from the bench to the top of the string and the length of the string, and using sine theta upon h upon L, you find theta, right? So that is another method that you can suggest, right? So you should be able to explain what the independent variable is and how to measure it, dependent variable, what is the dependent variable and how to measure it. So now we have addressed them both in this particular situation. Now we have to now you have to actually mention at least one. Always make sure at least one, preferably more. You have to mention what conditions and what quantities you are going to maintain as constant variables, so control variables, right? So now when you have in this particular situation, if there is a very very fast, the faster wind would create a lot of a significant deviation. That means it would get deflected very much with a slight change. So then you might want to use a mass as shown in the diagram in the earlier pages. So then it would not get deviated as easily as in under normal conditions, right? You might want to change that, right? You might want to change the mass. If it gets deviated a lot, then you might want to use a heavier mass. So like that you have to control them. Then how do you maintain the temperature of the inside of the balloon? So you keep this balloon, this inflated balloon, you keep it inside a room, inside the laboratory or wherever you are going to carry out the experiment for several hours until the temperatures are the same, right? And then the fan used would blow air from the room, that is the inside of the room. The same air needs to be blown towards the balloon. That is also something that you can mention. So these are the control variables, and how do you control them is also should be written. So now the next step is you draw the now you have a very good idea about what is happening, what is being measured, what is being changed, and how to measure it. All of those things are there. So now you draw this, you use a label diagram. Now you mentioned a lot of things. You have to include all of those things in the diagram. You draw the fan, the supply of the wind as well as the supply of the power. Then you use a protractor, and you can also draw an anemometer. And then using words, you explain your experiment. So you have to explain the logical sequence of steps that you need to follow. First you do this, then this is what is going to happen. Then you do this, then as a result this is going to happen, right? So then that will also, if you can include those steps also into your diagram, then it would be useful. uh, Now, so this is going to be important. Now, for example, the wind speed, where are you going to place the anemometer? So these details will have to be included into the diagram. Then, to get more points, right, you might have to give additional details. That is, other than these things that we mentioned. Now, the additional things, now in relation to this particular activity, we have to use a significant change with the wind change. That is, if it ranges, if the from the lower speed to the higher speed, if the change is only about 5 degrees, then it is insignificant for us to measure. But if it is changing from 90 to, that is, initially if it was like this, balloon was like this, and then finally if it was something like this with this angle being 30 or something like that, then that is a pretty good change. So that would be, those details might be additional details. Those details are not very much important as any of the other three, and also they do not belong to any of those stuff. So but you can explain these things, right? So that is, those are the additional details that you might have to say. Then you have to talk about the other things that the other difficulties that you might experience. Then the draft should be avoided. Draft is another wind that is coming from somewhere else. The effect of drafts. So that would be, because if there is a wind flowing in another direction other than from the fan, then that would also affect. So you might want to explain this as well. So if you say that, then the person who is reading the answer would know that you have paid attention to all of the details, and they are highly likely to give you more marks, right? Then the final one is safety. So now in this particular experiment, there is nothing for you to be in a realistic level. For an A-level student who has done physics, there is nothing that person would do to cause any harm to herself or someone else. But the thing is, when you are talking about an experiment, you must make sure, even though that it would sound stupid, even though it would sound absurd, you must make sure that you mention what kind of precautions need to be taken. Right? You might feel that the risk is unimportant, but still you have to mention it. Sometimes it would be sufficient to explain that you have to wear goggles. But you need to, when you are saying when you have to say wear goggles, you can't stop from there. You have to explain why you need to wear the goggles. You have to, for example, you might say wear goggles to protect your eyes from the wind. Then you might say take precautions to keep away from the rotating blades of the fan, right? Or else, to avoid electrocution, use protected or covered power cables. Some things like that you might want to mention. And also always remember to mention more than two at least two safety precautions that you should take, right? So there are using goggles is a very common one when dealing with heated liquids or handling stretched wires or dealing with wind, etc. Then you can use that. Then using safety screens and making sure the apparatus are stable or fixed, right? and then using a sand tray to prevent heavy weights from falling onto your foot, and switching off currents when the experiment is not being conducted. So those are very important for you, right? Right, let's look at this worked example, and after that let's write down a note, right? So this will give you the detailed examples of how this is done. Plan an experiment to measure the resistivity of glass, which is about 10 to the power 10 to the power 10 ohm meters. You have available a number of sheets of glass of the same size but with different thicknesses. Resistivity is defined as resistivity rho equals Ra upon L. So they have given the equation. Now you need to plan the experiment to measure the resistivity of glass, right? So the resistivity is what now you need to, everything that you know about resistivity should come flooding into your head. So the resistivity of glass is about 10 to the power 10 ohm meters. Then they have given the instruments. You have available a number of sheets of glass of the same size but with different thicknesses. Resistivity is defined as rho equals Ra upon L. Now we need to identify the variables. Now what are we changing? They have given glasses with different thicknesses. So we change the thickness of the glass. So the independent variable is the thickness of the glass. The thickness is identified as L of the glass. Then what is the dependent variable? The resistance of the glass. So we are going to find R. Then how do we find R? We measure the PD across the glass and the current in the glass. Then the control variable is the area of the glass. We need to maintain it constant. This is already mentioned in the question. So as a result, you have to add something else as well to this. Then you can mention we maintain the temperature a constant, right? Now how do we collect the data? So this involves how do we change the independent variable and how do we measure it, and then how do we measure the changes of the dependent variable. Then how do we maintain the control variables, right? Here it says to alter the independent variable, use glass sheets of different thickness but same area. The thickness of each piece of glass is measured with a micrometer at several places and averaged, right? So that is what you do. And this might not, you might just stop at saying, take the thickness the same. But you have to mention, if you mention that you take the micrometer measurements, because you need to measure the micrometer, you need to measure the thickness. So how do we measure the thickness? Using a micrometer. Then we need to measure the area. How do we measure it? By using a ruler and multiplying the values together. Then you need to draw the circuit diagram of the here you have to draw an ammeter in series with the glass sheet and a power supply. You have to across the glass you have to have a voltmeter, right? So that means it would be something like this. You have the glass, then in series with this you have an ammeter. Then across this you would have the voltmeter. This is the glass, and you have to mention what they are, right? I hope you understood. If you have any questions, please ask. Right, then right, So then then you have to actually practically think about how these connections are made. You can't just directly keep the wire underneath that. You will have to use aluminium foil or something like that. Then you might want to use metal plates as in a capacitor. So this will now the you need to remember when I drew the glass, I drew like this, but that is actually the thickness. So I measured the thickness, that is the other side is on the other side, that is the larger side is where you need to make a connection. Now if it was to be drawn realistically, then it would show like this. This would be the more realistic thing, right? And also you might want to use metal plates like this as in a capacitor. So you can mention that as well. You can draw that as well. So they should closely touch the large face of the glass sheet. And now this is how you actually do the learning. Now in the first step you might not get it right. Then when you go on reading the practical, and when you keep on reading the reading examples of these, you would be able to understand what mistakes you have done and improve on them. Then the readings that you need to take are the ammeter and voltmeter readings with how it changes with different thicknesses. Then you take these different thicknesses and the voltmeter and ammeter readings, and then now you need to give some sort of a sensible thicknesses of glass from 1 meter to 10 millimeter. You can't talk about nanometers and you can't talk about meters. So then you need to you should be able to understand these values, and you should be able to include these values. So please remember, you can't say about blocks of glasses like 10 centimeters or 20 centimeters, 100 centimeters. You can't mention about those things because that is not practical. Then what are the additional details that you need to do? How do you get a reasonable value? So these are the things that you need to understand and think about practically. Now when you think about the size and the thickness of the glass, you should be able to see a reasonable change in the dependent variable. Now for example, for the glass 1, if you have R equals rho L upon A, 10 to the power 10 into 0.001, which is going to be 10 to the power 7 ohms. Now this is a very, very large measurement. You can't measure this kind of a value. So you need to now in this one, the glass is 1 meter squared in area and 1 millimeter thick, right? So that is going to give you a 10 to the power 7 ohms. So we have to use 10 volt producing a current of 1 microamperes. That is measurable, but 100 volt will give you 10 microamperes, easier to measure but dangerous. So the thickness between 1 to 10 millimeter current we will have lesser than 10 microampere, then it should be able to measure lesser than that. So at least 1 to 10 microamperes or up to 10 microamperes, because when the thickness is the least, that would be the time when the highest current is going to pass through. So these things you need to have in mind. So you need to have an idea about the quantities that can be measured, and if the quantities are not measurable, you will have to put some sensible values to this by using the ordinary you are not going to have a super lab at your dispense, so you will have to, at your expense, but you will have to use uh, uh, actual instruments that you might find in a lab, right? So please be aware of these things. Then what are the safety points? So you have to take precautions when dealing with glass, because that can cut into person's skin, so gloves need to be used. Then if you are going to use higher currents or higher voltages, then use rubber gloves to prevent electric shocks, or then you can say insulate all the metal parts that are exposed. Then finally you write the method of analysis. So that means every derived quantity needs to be explained. So that means you are going to have, in this particular situation, you have to explain what is going to happen for each thickness and the voltage and current readings, and how it is going to relate to the formula R upon V upon, R equals V upon T. Right? So you use this R equals V upon T, and also because we have been given R equals rho L upon A, we have to plot a graph with R on y-axis and L on the x-axis. That will give us a straight line through the origin that will actually give us the value that is needed. So the gradient of the graph is rho upon A. So rho equals gradient into A. That is exactly what we need to prove. Right? So I hope you understood. If you did not understand, please let me know. If you understood the story, please go to the questions 2 and 3. Please do these questions, because these are going to help, and there is a high likelihood of these questions coming this time, because this is the new syllabus and the first time. Write down a note. When carrying out the experiment, we need to be able to explain of the method to be used to vary the independent variable, how the independent variable is measured, how the dependent variable is measured, and how the controlled variables are maintained, the arrangement of the apparatus using explanation along with a clear label diagram. When the experiment is described, we must include the instruments that we use to measure the different variables, and they should be sensible too. We might have to give additional details that might not belong to the variables that we described, but are helpful in maintaining consistency and obtaining accurate values. Finally, we need to mention the safety precautions we need to take. However absurd or insignificant they may sound, we must write at least 2 precautions we should take. I hope you understood. If you didn't understand, please ask questions, and please do question number 2 and 3 if you understood.